Hello everyone, welcome back to my channel in the journey to learn data science. In our previous series of videos, we have seen what is linear regression, why do we need linear regression, how can we apply linear regression, and on what kind of variables we can apply linear regression. So we have seen that on continuous variables we can apply linear regression, and if we have any categorical variable in a data set, then we need to convert that categorical variable into continuous variable. So in brief, we have studied a very short method of one-hot encoding. Now in this video, we'll see what are different encoding techniques and how can we implement those techniques in Python. So here we'll be discussing those techniques, what are the basics of those techniques, and what are the Python codes of statements that you can use to implement these kind of encoding techniques in Python. So let's begin today. So basically encoding is a transformation of converting your categorical variable into continuous variable or binary or numerical variable. So let's say if we have a category of gender, then in gender variable we have two categories, either male or female. To convert them, we use 1 or 0. But what if we have too many categories? Then how do we use 1 and 0? So to answer all these questions, we have different types of encoding techniques. And encoding of categorical variable into continuous variable is very much important for many machine learning algorithms, such as linear regression, support vector machine, neural networks, and many others. So we have basically three types of encoding technique. The one is ordinal encoding, the other one is label encoding, and the third one is one-hot encoding. So let's see all of them one by one. So ordinal encoding. Ordinal encoding is basically used to convert categorical features into numerical values. But if the categorical feature is of ordinal value, then only we can apply ordinal encoding. Now you must be thinking, what is ordinal? So let's take up a very simple example. Now, if you are going to a shop to buy a t-shirt, then you have different sizes of t-shirts like small, medium, large, and XL. So what are these? These are ordinal because these are in order. You know that smaller size is smaller than the medium size and medium is smaller than the large size. So you are following a particular order in a particular categorical variable. So to encode such kind of categorical variable, we can use ordinal encoding. Now, ordinal encoding is very similar to label encoding, but again, label encoding cannot be applied on ordinal categorical variable. So, ordinal encoding is very much important. So, let's see an example. Now, suppose a food restaurant wants to collect the feedback based on the food quality served. He has four qualities: poor, good, very good, and excellent. So, this is a categorical variable to collect the feedback. But I cannot apply linear regression on this particular categorical variable to predict the sales of a restaurant or to predict the price of a food item. Therefore, I need to convert this categorical variable into the continuous variable. So, for poor quality, I have used a Likert scale and I have assigned a value 1, good as 2, very good as 3, and excellent as 4. So if based on this rating of 1, 2, 3, 4, I can apply linear regression to predict the quality of a food or to predict the price of a food or to predict the selling price of a restaurant. So ordinal encoding is very much necessary. Next type of encoding is label encoding. Now, label encoding also replaces a categorical variable into a numerical value. But let's say if we have n number of categories in a particular variable. So, label encoding will generate a coding between 0 to n minus 1. Okay. So, let's take up a very simple example. In COVID-19, we have 6, 7 or 10 states in which the number of cases across India were too much. So, we have a arbitrary data set of six states, that is Maharashtra, Tamil Nadu, Delhi, Karnataka, Gujarat, and Uttar Pradesh. Now, if I want to predict the number of cases on these states, I cannot apply linear regression or a support vector machine or any other machine learning algorithm as it is a categorical variable. Therefore, I need to convert this categorical variable into numerical value or the continuous value. For this, I will use label encoding. In this example, we will take the first alphabetical digit of our state and then we will assign the value to it. So let's say the first alphabetical character is B from A to Z. So I will assign Delhi a value of 0. Next alphabetical character is G. So Gujarat will get a value 1. Next alphabetical character is Karnataka K. So Karnataka will get a value of 2 and so on. So this way we have encoded our categorical variable into continuous variable in the range of 0 to 5. That means we have 6 states. So label encoding, as we have just discussed, will convert into continuous value from 0 to n minus 1. So n here is 6. So it is converting from 0 to 5. So let's see the Python codes to implement label encoding. The first approach to apply label encoding in Python is using scikit-learn library approach. In this, we will create an instance of label encoder. So for that, we have to import sklearn preprocessing library, and in this library, we will import a module called as label encoder. After importing this module, we will create an instance of label encoder here, and then we will apply a fit transform function to the state. So the state is a categorical variable of the COVID-19 data frame. So after applying fit transform program to this particular state variable of COVID-19 data, we have applied label encoding and we have created a new column, that is state n, state new. So as a result, you can see that label encoding has converted my categorical variable into the continuous variable. Just as we discussed, Delhi got the value 0, Karnataka gets a value 2, Gujarat gets a value 1, and so on. So this is how you can implement label encoding in Python. Except this approach, there is one other approach, that is using pandas library. So in this, we can do the as type function. As type function will determine the type of my dataset the state variable is. Now you can see that state variable is of categorical type and the number of confirmed cases and deaths and recovered are of integer type, as it is a numerical value. So our aim is to convert this categorical variable state into continuous value. So we will write the state in bracket, that is the name of the column that we want to convert into continuous value of the data set, that is COVID-19, and we will write cat.codes. That means we are converting categorical variable into codes, and we will execute the cell. As a result, we will get this data set. In this, you can see that in the previous approach using scikit library, we were getting a new column. But in this, the original column of state has been replaced by the codes of the label encoding. So this is the second approach by which you can convert your categorical variable into continuous variable using label encoding in Python. Now the third approach is one-hot encoding. Let's see that. In one-hot encoding, we are creating dummy variables. So what do I mean by dummy variable? That means for each category, we are creating one new column. So let's take up the previous example only of COVID-19, where we have 6 states, Maharashtra, Delhi, Gujarat, Karnataka, and so on. So if we have 6 categories, that means we are creating 6 new columns. Now creation of 6 new columns has a disadvantage that it will increase the number of dimensions. But before going to that, let's understand this method of one-hot encoding. So we have applied one-hot encoding to our categorical variable state, where we have Maharashtra, Tamil Nadu, Delhi, Karnataka, Gujarat, and Uttar Pradesh. And as just discussed, we are creating a new column for each type of category. So these are the 6 new columns that we have created for 6 categories of our variable. Now, where the column and the row matches, we will write 1, and for rest of the columns, we will write 0. So you can see there is a diagonal pattern where we are having 1 for each state, and for the rest of the columns, we have 0. This is the way we have encoded our categorical variable state into binary value or continuous value using one-hot encoding. But as we just discussed, this method has a big drawback, that it added 6 new columns in my dataset. It is causing curse of dimensionality, because number of columns means number of dimensions in the dataset, and more number of dimensions is called as curse of dimensionality. So this method is only used when we have a small dataset or small number of categories in a particular variable, so that we can reduce the curse of dimensionality on our dataset. So this is curse of dimensionality is also referred to as dummy variable trap. Now let's see the Python encoding for one-hot encoding. So the first approach again is scikit-learn library. As we created an instance of label encoding in the label encoding part, we will first create a one-hot encoder instance after importing the sklearn preprocessing library and a module one-hot encoder. After importing this module, we have created an instance, and in this instance, we are dropping our first column. What do I mean by first column? That means for the first category, that is Delhi, I will not do the encoding part because I am doing the encoding for the next 5 states. So I will exclude Delhi because the whatever coding has been assigned to different states, Delhi will automatically get its code. This is just done to reduce our dimensions. So after creating an instance, we are applying the fit transform program on our categorical variable state of COVID-19 dataset, and we are storing the result in the new data frame, that is one hot encoder data frame. In this, the result of this data frame is this. Now, as I say that we have removed our first column. So the first column is for the first category, that is Delhi in the alphabetical order. So see, in Delhi, we have all the values as 0000. That means the first label that has been assigned to Delhi is 0. Next, we have applied, next is Gujarat. So Gujarat gets a value 1 here. Uttar Pradesh gets a value 1 here at the fourth place. That means the first category will be Delhi. The second category will be Gujarat. The third category will be this variable, that is Karnataka, where the first column has one value. The fourth value will be of Maharashtra, where we have one. The fifth value will be of Tamil Nadu, where we have one here, and the sixth value will be of Uttar Pradesh, just like label encoding. So after creating this new data frame, we will join this new data frame with the original data frame. So we will join this new data frame using a join command, and we can see that Maharashtra has a value that is being assigned as a second value. That means first it has been assigned to Delhi, next it will be assigned to Gujarat, and followed by the other states. So in order to reduce one dimension, we have placed only five states as a encoding state, and we have deleted our first column. This is the method to reduce the curse of dimensionality. The second method here is using pandas library and the getDummies function. So in this, we have include pandas. So PD was an alias for the pandas library, and using pandas library, I'm using the getDummies function. So getDummies function will create a dummy data set. This is called my dummy data set, where we are encoding for each state. Here also we are dropping up the first column. So for Delhi, you can see all the values are 0. That means Delhi will be the first state, right? So get dummies function has been applied to my state variable of my COVID-19 dataset, and we are dropping the first column. So we have setting this value as true, and this is a new data frame. Now we have got the one hot encoding for all the states, just like the previous method, and then we are concatenating the new data frame with the original data frame using the pd.concat function. So it will concatenate my previous data frame of states with the new data frame of one hot encoding. So this is how we got the result. So the coding is same, but the method of implementation in Python is different. So this is how you can actually implement encoding in Python and a hands-on session. So if for more such interesting videos, for more such content on hands-on session, do comment me in the comment section, and please stay tuned to my channel. If you have not subscribed my channel till now, do subscribe my channel and stay awake for the more interesting videos. Thank you all for listening.